we have a pulley on an inclined plane question. So what we need to do is mark on all the forces first. We've got normal reaction for the particle resting on the plane. We've got weight, 3G, and we also have tension up and along the string. Okay, there are also two tensional forces acting on the pulley, equal in size because it's a smooth pulley, and we have a tension up the string for Q and a weight of 2G. Okay, the only one that we need to resolve is the weight force. So we have 3G cos 30 here, and we have 3G sine 30 here. Okay, so we need an equation of motion for P and an equation of motion for Q. What would happen if this system was released from rest? You know that Q would move downwards and it would pull P up the plane with the same acceleration. Okay, so we need to do F equals ma for each particle separately because they are not moving in the same directions. So let's do F equals ma first of all for P. We've got T, and then we've got minus 3G sine 30 equals its mass, which is 3 times A. Right, we do the same thing for Q. We do F equals ma. We have 2G minus T equals 2A. So that's all we had to do for part A. Part B says, hence show that the acceleration of Q is 0.98. So we need to obviously solve these two simultaneously. The easiest thing to do to get rid of T is to add equations 1 and 2 together. That will cancel out our T's. And then we will have minus 3G sine 30 plus 2G equals 5A. Sine 30 is just a half. So when you work out the left-hand side and divide by 5, that's how you get A equals 0.98. Right, so that's A done, B done. Find the tension in the string. All you have to do is sub back into either equation 1 or 2. Let's do equation 2 because it just looks a bit simpler. So you will have T equals 2G minus 2A. Put your A value in, the one you worked out previously, and you get T equals 18 newtons. Right, where have you used the information that the string is inextensible? The fact that it cannot extend means that the acceleration of particle Q and P is the same. So I would just write something like magnitude of acceleration, same for P and Q. Right, now they often with these pulley questions put something involving suvat, and you can tell that here because you've got these bits of information that you've not used yet. You've got height of 0.8 meters above the ground. You were told that it was initially held at rest. So let's write down everything we know about particle Q to work out part E. We know U was 0. We know that it travelled 0.8 meters before it hit the ground. And you know that it's got an acceleration of 0.98 downwards. So at what speed does it hit the ground? That's our final speed that we want. That's V. So once you've listed all the bits of information that you have, you decide what suvat equation you need. and it's v squared equals u squared plus 2as. Sub in all the values that you have. You've got 0 squared plus 2 times 0.98 times 0.8, and then you've got to square root all of that to get v, and you end up with 1.3 meters per second. Don't go too accurate with your answers where you've used g equals 9.8. So I would just stick to 3 significant figures or 1 decimal place.